Let's talk about factoring and solving problems after we factor them. Now this first one just asks us to factor out the common factor. Another way of saying that is GCF. So this one we don't need to solve, we just need to factor because that's all it says. It's also not solved for 0, so that's another giveaway for this one. So two terms, that's not an A, B, and C, that's just a 2-box. Put your first one in the first box, your second one in the last box. Just make sure that you keep your signs if it has it. And figure out what 24 and 40 have in common and put it out to the front. So they are both divisible by 4, but there's something bigger as well, 8. They're both divisible by 8. So let me pull that out. And then look at your m's. This one has 4 m's, this one has 3 of them. So in common they have the smaller amount, m to the 3. Now let's put what's left over after we take that out. You're probably a little bit better at this and probably can skip right up here now. But if not, go ahead and divide by 8m cubed. So we divide by our GCF to see what's left over. So we get 3m and we get 5. So those m cubes cancel on that one. Notice our exponents subtract just like normal. So our GCF is 8m cubed, and the way we write this is parentheses what's left over. So it looks like a distributive problem when you're done. Once again, we don't have to solve that one because it just asked us to factor. So let's look at one where we do need to solve it. Now here's an example of one that's not solved for 0 yet. We've got our m squared, we've got our m, and we've got the 6 over here. We need to make sure that all this stuff is over there with the m squared. So when you switch the sides, switch the sign. So our 4m squared with a negative 10m now and a positive 6. Make sure it is in descending order, and now the only thing on that side is an equals 0. So descending order, our exponents go downhill to none. Now we need to see if we can take out a GCF, see if we can make this simpler. Hey, 4, 10, and 6, those are all even numbers. They're all divisible by 2. So if I pull out my GCF really quickly, oops, I changed my sign on that one. So I need to put in my negative there. I lost it, so I had to write it above. I pulled out my 2 because all of these were divisible by 2. So you just went through and divide them by that. Now our GCF here is one of our factors, but it does not have a variable in it. Because this isn't 2m, I can actually just throw that out now. I don't need it for this equation. So if it doesn't have a variable, it doesn't matter. So now I can just go and factor this. So I've got my first term in my first block, my last term in my last block, and I'm going to split those m's in between these two. And to do that, I need my a, my b, and my c so that I can multiply my a and my c together. So a is 2, b is negative 5, don't lose that negative like I almost did, and my c is positive 3. So a times c is 6. Now I need to pick two things from that multiply to 6, but still add to that b right there. So they multiply to a positive but add to a negative. I know they both have to be negative, and I'm thinking 2 and 3. Multiplies to positive 6, adds to negative 5. So I'm going to put my 2 with my other 2 and my 3 with my other 3. So I can pull out the GCF, 2m, to the side here. So then what's left over? An m. I've got 2m here, negative 2m there. I've just got the negative 1 left over because it almost matches exactly. Now here I've got a sign of negative 3. So I need to make sure I pull out that negative. And then I have an m and a negative 1 again. So that is my check just to make sure I pulled out the right thing. So my two factors are 2m minus 3 and m minus 1. So it's at the point where we need to go ahead and solve this. And I know it because it has the equal sign. That means we want the solutions here. So my first one, see what sign it is. It says negative 3. So we say positive 3. And the coefficient goes to the denominator. So that's positive 3 over 2. So don't change your signs of coefficients, only of the second part over here. And then this one doesn't have a coefficient, so instead of saying negative 1, all we have to say is positive 1. And there we go, our solutions. Our next problem, that's not it. It's actually easier than that one. Look at it. We've got a factor and a factor equals 0. So solve each equation by factoring. All I have to do is switch my sign. So my negative 3 becomes positive 3. and my coefficient goes to the denominator. So this is v equals, and I put these nice little brackets, and there we go. Oftentimes the SOL doesn't ask for both of the solutions. Usually they'll just say which one of these is a solution. So they might mess up one of their signs on one of the others, or they might just not give you one entirely. But make sure that you don't mess up by looking for both of them when it's just asking for one. And one last one that I want to go over with you today. It's 2x squared minus x equals 3. That should say equals 0. So let's move that 3 to the other side. When I switch the side, I switch the sign. So that's 2x squared minus x minus 3. So it was a positive 3. Now it's a negative 3. I'm also going to put in my Ninja real quick to make this a little bit easier to look at. And I'm going to have to factor this. So I have an x squared, an x, and another number, a trinomial. So let's go ahead and do my ABC. So 2, negative 1, and negative 3. So what is A times C? So I've got my 2x squared, my negative 3, split up those x's. And A times C is negative 6. And I think they already told us the numbers we needed. So 2 times negative 3 is negative 6, but it adds to negative 1. So I'm going to put those right in the proper spots. That makes sense. Then I know I can pull out a 2x, get an x left over my first term, and 2x, 2x, make sure you put a 1 left over there. Then we can pull out our negative 3, which gives us an x and a positive 1 again. So my two factors are x minus 3, 2x minus 3, and x plus 1. So when I go for my solutions, and I know this because it says equals 0, and the directions will say solve, switch your sign. So positive 3 over 2, coefficient went to the denominator. And right here, my positive 1 became negative 1. So those are my solutions.